Better Than Earth by Sam Illingworth. Mechanical eyes sweep immeasurable skies, searching for life with boundaries predefined by the limitations of their homely existence. Blistered hands reaching into dusty bags to pull blue marbles from a kaleidoscope of planetary possibilities. Not younger or smaller, but warmer and wetter. These are the states in which life would be better. Habitats that turn our planet green as it nervously shifts explorations to the watery blocks upon which we are stacked. All right, so that was a poem by a fellow named Sam Illingworth, who is not only a scientist, but clearly also a poet. If you guys did not quite understand what that means, it is about exoplanets, particularly exoplanets that may harbor life. If you want to read more about that, just go to the poetryofscience.scienceblog.com. All right, so for new time listeners, you are currently watching Sg2 On Space. This is your host, Shinga, that's me, and my co-host, Leonard Kramer, in his very distinctive butterfly something outfit. Wonderful, and the headband, love it. So today we're going to talk about exoplanets, but before we start jumping into our conversation, let me go with the spiel. Follow me, facebook.com/theshenshow, SHEN. You can watch all the episodes on YouTube. Just look up SG2. That's my initials, SG, and then the number 2 on space on youtube.com. And there will be over 60 episodes. We've been doing this for quite a while, guys. And of course, feel free to support me since the show does require a little funding. So support me on patreon.com, patreon.com/SG2 on space. So thank you. All right. Now, without further ado, let's talk about our main topic of the day, which is on exoplanets. So first of all, the definition of exoplanets. Leonard, do you have one?
A planet outside of our solar system.
All right. I mean, that sounds highly reasonable. All right. So exoplanets, this seems to be, prior to the show starting, you and I were chatting, you said this is a golden age of exoplanet discoveries. Now, when you say that, what do you mean?
Well, I mean, the first exoplanet was, definitively discovered really in the about 1995, and before that, when I was, a young person, we didn't know that there were, it was problematic or a question whether there were any planets outside the solar system. I think everyone just sort of assumed they were, but there was no proof of it. And so coming when the mid 90s came along, we had some good evidence of that, and since then it's become all the rage with NASA funding lots and lots of space telescope missions, including the Kepler space telescope and some others that are coming online. So now we have definitive evidence of literally thousands of these exoplanets. Exoplanet is a planet that is in a solar system that is remote from Earth's our solar system. So it's quite remarkable, and we're gearing up to learn more and more about them. We're starting to understand that every solar system is different, just like one of the things that I've always been fascinated with in planetary science, just within our own solar system, is that every planet we look at is completely different from any other, and that's, to me, that's kind of remarkable, because the way solar systems form, I think, is pretty well understood. Has to do with an accretion disk, that a cloud of gas and dust that condenses, and then with a central star that will start burning hydrogen, and accretion of bodies around it. So from this, mixed up gas and dust, accretes a bunch of unique things that are orbiting around it, and that's, to me, that's sort of surprising. And it's looking like every place we look in the universe now, or in our local galactic neighborhood in the galaxy, we're seeing a great variety of different objects. Now, we don't actually, well, there are some direct observations of these stellar systems, but for the most part, we infer their presence through the effect they have on the motion of their star, and also on the movement of the planet in front of the star. So, did I answer your question?
I think that was quite a long exposition, but it was quite informative. Wow, nice coffee mug. So now, you said back in 1995, that's before, I think, any space telescopes were launched to specifically look for these exoplanets. So I think it was a ground-based telescope. What was, do you know how they did it, and what was it? I've heard that it was kind of surprising, because it was a planet that was really close to that star system, which I think was like at least the size of Jupiter, if I recall. I think that's what it is.
It was a very big planet. The first ones were big because they had the most influence on the motion of the central star. I could be wrong about this, but I recall that it was a Doppler measurement. In other words, they could see that the motion of the central star was shifted by the orbit of the planet. When two objects orbit each other, like a star and a planet, they actually, the star also is orbiting around a barycenter with a center of mass.
Hot Jupiter.
Yeah, hot Jupiter. Why are we talking about hot Jupiter?
No, what? No. Did you hear what I said?
Yeah, you said hot Jupiter.
Hot Jupiter are those planets, like massive planets that are close to their star, which is like So that's why I said it.
Oh, okay.
Yeah.
Well, it's not the heat. It's not the heat. It's the motion. In other words, as the planet orbits around its central star, it perturbs the motion of the star and causes it to alternately move away. There's a component of its motion away from us and then toward us, and we can detect that with very precise Doppler measurements. We also have transit measurements, which is the real productive method that was used. But these original measurements, or these original studies, were done in South America, and in the Andes. There are a number of ground-based observatories that are at high altitude and clear sky and all that good stuff.
So essentially, for our listeners' sake, if I'm understanding this correctly, the initial observations were done from ground-based telescopes, which could only observe these larger planets because the technique used was a Doppler shift method, where essentially they looked at how much the stars was perturbed by the gravity of whatever massive planet was orbiting it, and they could
Correct.
observe that. So, but
Yes.
later on, now we have space telescopes which could use other techniques. So, for instance, one of them is what you said is a transit, which is essentially when a planet moves in front of the star, it blocks some of the light, so the light curve is slightly reduced, and it will follow a periodic motion, and since it keeps orbiting, and hence you can do some analysis and deduce from that what the size of the planet is and
That
how far away it is.
that's correct. Now the downside to that is that in any solar system, that doesn't happen very often. In other words, in our solar system, we have the opportunity to witness a transit of Venus or Mercury, and it's really rather rare. You might see it once or twice a year, for the inner planets that orbit between Earth and the Sun. But so it requires continuous measurement of a large number of bodies, and so the large number of stars. So the remarkable thing about the Kepler mission was that they put the Kepler was a space telescope that was in solar orbit. It was in orbit around the sun, and it looked at a special region of the sky continuously, and I mean continuously, and looked at and simultaneously observed something like over 100,000 stars, and then through transmitting that data to Earth, and then processing of the light curves of those, we would see occasional reduction in the stellar output because one of its planets had moved in front of it.
Right, in front of it.
And through that process, we've detected, I don't know what the last count is. I think it's in excess of 5,000. So
yeah, I mean, it did last 9 years, from 2009 until October 30th, 2018, which I guess that's about 2 years ago that it retired. So in those 9 years, it discovered, I think, over actually, you know what? I'm looking at it now, and apparently it discovered 2,662 planets, and it observed 530,506 stars. So yeah, it does take some luck to have a planet in front of it and getting that data. But like almost 3,000 planets is really impressive just with one telescope.
Right, and I think you can look up the other follow-on mission, which is called TESS, which is I forgot. It's
Transiting Exoplanet Survey Satellite.
Right, and that's going to be a whole sky survey that will use the same method, and we should expect to discover 10,000 of these planets, and that's why I say this is the golden age. And then the follow-on mission to that are missions that will be studying the atmosphere of the planets using the transit method. So as a planet moves in front of its central star, we get a chance to examine the spectrum of whatever atmosphere is there, and so it's a big deal. I mean, it's a very exciting time.
So right now, with TESS, I know it's already up there. Are you saying it does not yet have the capability to observe what the atmosphere is, if the planet does have an atmosphere?
I don't know what the status is right now. I think they're just starting. I think they're just getting started. Maybe they started in June, and I haven't read anything reported yet, but I haven't heard any bad news. Like it is functioning. So they probably want to get all of their facts together before publishing, but that's what we should expect to to find out about the atmospheric composition and just be able to examine many more stars in that fashion. So the thing about that is that, of course, we're really it would be really exciting to find a planet that had substantial amount of oxygen in its atmosphere, or other oxygen is thought on Earth to be a product of biology. So if you see a planet far away that has a lot of oxygen in the atmosphere, then that's caused by photochemical reduction of something in the atmosphere, like carbon dioxide, by well, in the case of the Earth, it's caused by photosynthesis, and so that means a living things. We haven't seen that yet, but that's what we're after. And,
that's pretty amazing. So now I do know that so far we've discovered a lot of planets in what's known as a habitable zone, which one of them I found really interesting was the TRAPPIST-1 system I was telling you about, which essentially have 7 planets comparable to that in size to that of Earth, and it orbits. It's about 34 light years away, the star system, and these planets orbit I guess a red dwarf, but with that small star's, I guess, stellar output, as well as the distance away from the star, all those 7 planets are in that star system's habitable zone, which means liquid water could persist on their surfaces. So
yeah, I think actually 3 of them are thought to be in the Goldilocks zone, and one of them is thought to be too cold, and a couple of them are too warm. The really fascinating thing about that system, I think it's seven planets. Is that right? Seven planets. They're all probably rocky, rocky terrestrial type planets that are like the terrestrial planets that are in our solar system. So Mercury, Venus, Earth, and Mars are the terrestrial planets. The other planets are gas giants. They're much larger, so that's a bit of a surprise. I mean, I think, and the other thing is that they orbit extremely close to the central star. They all orbit closer than the orbit of Mercury in our system. The star itself is quite a bit cooler than our sun, I think, but yeah, each one of those seems to be a good candidate for a habitable planet, or a planet where something interesting like biology might be taking place.
Right. There's a good picture. I don't know. I guess there's a good picture which actually compares the TRAPPIST-1 system with that of the Jupiter system. And the distance, you can see that all the planets that's to the star is comparable in distance to of the moons of Jupiter, the Galilean moons.
Oh, I see. Yeah. Okay. Mm-hmm.
I mean, it's really interesting, and you're right. I mean, these planets are orbiting the star at an incredibly small distance, comparatively compared to our solar system. So, it'd be interesting.
And
now,
it's also relatively close by, right? So, there, it's 30 less than 40 light years away. And the thing is, one of these days, one of these days in the next 10 years, we might read that life has been discovered on one of these on one of these extrasolar planets, and I think it would be one of the greatest discoveries in human history. It sort of reorient our whole imagination about the universe and and
Let,
be a very great discovery.
let me ask
Don't
you
you think?
this, Leonard. No, of course I think so. In our own solar system, obviously Earth has a lot of oxygen, hence we're alive and breathing right now. Um, are there in our own solar system, are there moons or planets that also have a decent amount of oxygen?
No, no,
No,
we
right?
haven't. No,
Okay.
there's only one planet in our solar system where photochemical reduction of carbon dioxide is occurring, and it's
Got it.
through a very complex chemistry that occurs on the Earth, and we otherwise known as photosynthesis.
Got it.
So,
Got it.
so that really would be a signature of life. Now, we don't know uh, how life forms. In other words, we only have one sample of that on Earth, and we don't
Mhm.
know how to do it in the laboratory. So we don't know how to create life in the laboratory. So it's a question whether it's common or not. But I I have a feeling that of the the billions of stars out there, that we will find a planet that has an oxygen atmosphere, which would be the signature
Is
of life.
if we win, I'm gonna go with win. When we find such a planet, um, is that saying from what you're saying, it seems like that's for sure is life. But of course, how can we actually be sure? I mean,
Well, I mean,
it,
that's kind of like our human nature is to always try to find uh, some other alternative to that. And
mhm.
I am a believer in falsifying, finding reasons why you're wrong about things. But we don't observe oxygen atmospheres, I mean, anywhere except on Earth. And I think we would have a real challenge on our hands to, if we do find a planet out there that has a saturated oxygen atmosphere, say 20% oxygen, which is the Earth's atmosphere is about 20% by
Mhm.
volume oxygen. If we do find a planet like that, and we will be able to, with the measurements that are being proposed, we will be able to discern that if it exists. Um, and we have 10,000 candidates to look at so far, or we will very soon. Um, I just think
Besides,
that I think it would be
mhm.
quite a challenge to try to explain an oxygen atmosphere outside of photosynthesis.
No, I mean that definitely makes sense. I want to point out another telescope which I found really interesting besides TESS and Kepler. Have you heard of Gaia?
Yeah, isn't that the European effort in
Yeah.
this
So
endeavor? Yeah.
it's not meant to just look for exosolar planets. It has a highly ambitious goal, and it's been operating since 2013, scheduled to operate until 2022. But it's designed for astrometry, which is measuring positions, distances, and motions of stars and other astronomical objects. Um, and and it wants to. The purpose is to construct like the most precise and largest 3D space catalog ever, which is going to have like about 1 billion astronomical objects, which includes stars, planets, comets, asteroids, quasars. Um, According to some study, apparently it could detect like not just exoplanets beyond our solar system, um, but like actually, yeah. Now it I'm not saying that it could do what TESS does, but it's also really helpful because I think it covers like a much wider area of the sky. Um, but the size limitations with that though is like Jupiter size, whereas I think TESS can go much smaller. So we got a whole range of these telescopes which can detect all sorts of different size, mass exoplanets, which is really cool.
Hmm.
I'm pretty excited about it. Now, um, So do you have a favorite one, or have you thought about it?
A favorite one what, Shen?
Favorite world you want to go to?
Oh, well, I like Disney World.
Oh, okay.
But
Hey, so do I. All right.
I don't know. It would be pretty exciting to be able to see that, but I think I'd be content with pictures being sent back. I don't think I don't think we'll be able to make it there in my lifetime. There are proposals for for actually, believe it or not, some
Hmm.
interstellar missions to fly spacecraft, tiny little spacecraft that are the size of um, like a golf ball,
Hmm.
and using very high intensity lasers. I forgot what it's called. I forgot the name of of the
I th-
of the program. Um, but I think it's something like, you know, light shot or fast shot, something.
Star shot.
Star
We talked
shot,
about
yeah,
that last time with the light sails. We talked about that.
right.
So
So
yeah.
the idea is to use it to have a little spacecraft that deploys an inflatable sphere that's shiny, and then you have intense lasers that will uh, shine on it from ground based, probably on, maybe they could be on the moon or someplace like that, and you can accelerate it up to about a tenth or maybe a little bit more of the speed of light, 1/10 the speed of light, and get
Hmm.
to say Alpha Centauri, which there is Alpha Centauri is a trinary system. It has three stars there, and there are planets. And one of the planets is thought to be in the Goldilocks zone. But
Ooh.
yeah, and so it's 10 light years away. So at a tenth the speed of light. No, it's 4 light years away. So at a tenth the speed of light, it would get there in 40 years, which is just inside the lifetime of of some of the younger people. Um, and and uh, and the way it would send, and I don't think they can do any kind of instrumentation or anything, but it should be able to take pictures. And the idea is that they would send tens of thousands of these. So it'd be like they'd be sending like a machine gun of these little postage stamp or golf ball size spacecraft, accelerate them
Hmm.
up to the speed of light, and it doesn't look like there's any kind of like show-stopping or unreasonable assumptions about the technology needed to do this. So we could accelerate it up to that speed using lasers from the ground,
Hmm.
and then as it's approaching, say if it's Proxima Centauri, which is 4 light years away, it would take 40 years, um, and it would zip through there within a few hours. Like it would, it would be going so fast that it wouldn't have very much time to really do anything other than take pictures, and then it would have somehow it would have a little stored amount of energy where it could send that back to Earth with with a uh, a laser, and it would
That
take 4 years for the signal to get back. So we're talking about a 45 or 50 year mission,
it's
and
completely doable.
using tens of thousands of these little and so we'd be sending them out. So you folks can read up on that. It looks feasible, looks reasonable to me.
I think
So
that's a reasonable target as well. The Proxima Centauri system, or
right.
yeah.
And the thing is, if as I was saying, if in the next 10 years we hear that, oh, this system has oxygen in its atmosphere, and here's another one, and here's another one, and if we find, that there are 10, 20, or 30 or 100 planets out there with oxygen atmospheres, or some other indication that there's life occurring, I think that it would really turn around the mood of people and their attitude toward this kind of science. I mean,
I agree. I think
you know,
think broader. With that said, Leonard, I think our time has come to a close for now.
wow, it
Uh,
sure does
yeah,
go by fast, doesn't it?
I know. When you're all passionate about a subject,
Yeah.
that's what happens. So with that, guys, follow me, facebook.com/The Shin Show. If you missed this episode, or if you want to see previous episodes, just go on YouTube, look up Sg2 On Space, and support me at patreon.com/Sg2 On Space. And with that, thank you, Leonard, for always being entertaining here. All right, you really don't have to do that, but all right. So with that, gotta say the catchphrase: look up, because you never know what you will see. Who knows? You might not be able to see an exoplanet, but you'll be able to see those stars at least. All right, and you get to see the cow coffee mug too, possibly. All right. Anyways, with that, take care, guys.
Bye.
Have a great night, and
Good night.
that's it. Good night.
Bye, y'all. Thank you.